Alrighty, everybody, welcome back to another episode of Subscribing to My Podcast. Because I have a new guest featured every week, it makes it very difficult to maintain consistent viewership. So if there's one thing that you can do to support me or the guest featured on the show, it's by interacting with my channel in every way that you can. You can always decide to unsubscribe later if you decide that you hate me or my show. With that plugging aside, enjoy my discussion with Dr. Xander Toftness is a professor at Coe College up in Iowa of psychology with a specialization in the brain and neuroscience. The way that I found him was actually through his YouTube channel, Art Explains Science and History, which I found really interesting. It talked about a lot of the ways that your brain can break, which is a very interesting series with applications in some of these fields. And I'm a psychologist, but this is definitely in an area where if this isn't your specialization, it kind of scares the crap out of you because it's very biological and sciencey. So I'm very excited to talk to him and see and learn from some of the studies that he has done. But I guess, Xander, why don't you go ahead and introduce yourself and then tell some of the viewers the important things that they should know about you.
Sure thing. Happy to be here. My name is Xander Toftness, and I am an early career professor. I finished my PhD in 2022 at Iowa State University. So I am smack dab in the middle of the United States, if you want to think about it that way, because now I am still working in Iowa. And you are entirely correct. My field of discipline is intimidating. Just yesterday, I was speaking with a prospective student who is thinking about majoring in psychology in our department. So occasionally I'll talk to students that are thinking about becoming a college student there. And when I mentioned the biopsychology class, which is kind of like my bread and butter class, I teach it every semester, she immediately said, "Oh, I don't know about that one. It's a little bit intimidating." She said something along those lines. And I like to think that by the time a student is done taking their first neuroscience class, they realize that it's not nearly as scary as it seems at first. It definitely does have biology in it, and yet it is still the science of people at the end of the day. And because people are obsessed with people, people are usually very motivated to learn the topics that we talk about in that class, for example. I also teach drugs and behavior. So I get into psychopharmacology, and I teach an upper level course called behavioral neuroscience, which is, it's a lot. We talk about everything in that class, sort of the edges of neuroscience, everything that we think we know. But my book, Incredible Consequences of Brain Injury, The Ways Your Brain Can Break, is what you're referring to. In fact, when I pitched this book to my publisher at first, the subtitle and the title were flipped. So I said, I want to call the book The Ways Your Brain Can Break. And they said, I don't know, what if we make that the subtitle, right? Sounds a little bit too informal. But my point there is that I've always been more of a science communicator, right? I've always wanted to make things accessible and approachable. So I like to think that when I teach a neuroscience course, students come around and they realize that it's not so scary once you start really getting into what's really happening in the nervous system.
Yeah, well, and I think one of the things that you specialize in, and this is apparent in your YouTube channel where you kind of communicate and break down some of these ideas, and then obviously your classes, is that this stuff can be interesting, this stuff can be accessible, and this can be stuff that you deal with or actually influences the way that your brain is every single day. I think an interesting implication of this is a lot of the sensory and perception side of these things. So this would be like there are some common illusions that I know get presented in a lot of these classes where you're interpreting something that's different than how it actually is. There's the very famous dress, the gold and blue dress, right? And stuff like that. I guess from your perspective, if you were to try to rope people into this study and to show them like, look, this actually affects you, this is how you perceive things. How do you kind of communicate this idea to maybe some laymen's who, don't understand the impact that these things have on them?
Yeah, my starting point is always that you are a brain. Everything psychological is simultaneously biological. And a great way to start is by talking about sensation and perception, most notably optical illusions. I think one of the most accessible ways to start getting into that area is this book, which came out pretty recently. It's called An Immense World by Ed Yong. And he uses something that pretty much everybody likes, the animal kingdom, to give examples of things that animals can perceive that we are not able to perceive. And in doing so, he sort of creates this disambiguation between the terms sensation and perception. So sensation is the actual environmental information. So for instance, light is, depending on, let's not get into the physics, but it's both a particle and a wave. And when it hits the retina at the back of your eye, your brain begins this process of transforming it via brain cells, neurons, into an interpretable signal that then becomes your perception. So sensation is out here, perception is in here. And the key thing to understand about sensation and perception is that even if you give the same two people the same sensations, they might have wildly different perceptions. This is obviously true across the animal kingdom. We've got birds that can see colors that we're not able to see. We've got elephants that can hear sounds that we're not able to hear. Probably the most accessible example is the dog whistle, right? A dog can hear sounds that are higher pitches than a person. But it goes much deeper than that, because there are also situations where we think we're seeing the world as it is, but we're actually not. We're doing something where it feels like we're seeing the world as it actually is, but because of something called top-down processing, we're actually creating a situation where we are being tricked. So here, for example, I have pictures of 3 different tables. This is pretty easy to find an example of anywhere. There are lots of different versions of this. There's also a version of this that uses sarcophagi, which is kind of fun. And the idea is that if I ask you which 2 of these tables have the most similar surface, what should happen in most people that I ask this question to is that they say that the 2 tables labeled B and C have the most similar surface area. But the reality, and if you've ever, I mean, we already talked about optical illusions, so I think most people will be able to say that can't possibly be right. He's tricking me. And I am. It's actually A and B that have the exact same surface area. If you were to use a pair of scissors and cut out A and overlap it with B, they would be identical. The fun part about this is that I actually do this demonstration. I did one at the Des Moines Art Center recently. I also did it at the Ryman Gardens in Ames, where I will provide a printed out sheet and a pair of scissors, and you can cut out the tables and overlap them. But until the moment that they're actually overlapping, people still don't believe you. Because your perception is not just using information from the external world in order to make its judgments about what's out there. It's also using information inside of your brain to try and make sense of the world. We don't see the true world. We see a version of the world that has been simplified. It has been summarized. And there are several steps to this simplification and summarization, but you can think of it as, even though we have 86 billion neurons approximately in our brain, very few of them are actually involved in the conscious perception part of perception. A lot of those cells, what they're doing is sending zeros and ones to each other, effectively. I'm simplifying here. And they're processing information, but they're trying to take this crazy, immense, wonderful, beautiful world and pare it down in a way that we actually have enough bandwidth to understand it. So optical illusions are perceptions, and they are sometimes inaccurate, right? There's lots of other great examples of these. This book has a few. I've got a bunch more at my office at work. This one right here, if you look at the top image, it should look like a spiral, yes? But if you look at the bottom image, you can see that I can draw a circle, that black circle right there, such that this is actually an image containing circles. But no matter how much you look at it, because your perception, your visual system that leads to your perception of the image is selectively interpreting the information, there's really nothing you can do to escape this illusion that it is a spiral as opposed to a group of circles. Now, if you try really, really hard, you might be able to like see the circles for like a second, but then you sort of pop back out. So this leads me to a really important disambiguation before we talk about brain injuries. And that's this difference between illusions and delusions. Illusions and delusions are different enough in my field that it's worth explaining the difference. So an illusion is something that you are perceiving and you are really experiencing it. So that first top image of the spiral, you are perceiving a spiral. It is an illusion of a spiral, right? Or with the tables example, it's the illusion that A and B are different sized tables. So it's the actual perception that you are experiencing. A delusion, on the other hand, is a belief. A belief in something, such as I believe that the tables are the same size, or I don't believe that the tables are the same size. And in optical illusion research, what you can do is you can cure somebody of the delusion. You can teach them, for example, actually, this is a picture of circles, not a spiral, or these two tables are the same size. And by showing them, getting them to cut out the table and overlap it, for example, you can get rid of the delusion. And yet, if you go back to the original image of the tables or the spirals, the illusion is still there. So in some cases, we can't really bust a person out of the illusion, even if we find a way to cure the delusion, right? So what I actually study is brain injuries that change the way that people perceive the world. This is a very depressing field sometimes. So optical illusions are often very bright and cheerful and wonderful and colorful, right? But then as I continue my explanations and my studies, I start talking about people who have had a stroke or a brain tumor or a severe concussion, something along those lines. And something in their brain has broken, as I say, in the ways your brain can break, such that they used to be able to perceive something, and now they are no longer able to do so. A really key example is the very first chapter of the book, which is about achromatopsia. Somebody who was able to perceive color, but because of an injury to a specific part of their brain, they lost the ability to perceive color. So the part of the brain that's involved in perceiving color was controversial for a very long time. But when they eventually agreed on it, they called it V4, and you actually have two of them, one in each of your hemispheres, back here, towards the back of your head. And if you are misfortunate enough to have that area of the brain damaged, either on one or both sides, you lose the ability to perceive color. And in fact, a lot of reports will include the ability to see color in your dreams is also lost because you don't have the part of the brain that interprets color anymore, essentially. And this is a key example of how a brain injury can change the perception of your world, such that it can really affect people. It can really affect people. The most famous example, there was an artist who lost the ability to see color. And in order to try and get people to understand why it affected him so much, he created a museum exhibit with a table with a bunch of food on it. And he painted everything gray so that people could walk into the room and sit down in the gray chair at the gray table and look at a gray glass of orange juice and really see how perception of the world can matter, can really affect a person. In his case, very emotionally.
Yeah,
There are a ton of other examples in my book. There's 48 chapters, and I go through all kinds of stuff, some of which are a little bit more wild than others. But acquired color blindness, achromatopsia, is the one that I always like to start with.
Yeah, and I want to stay on vision a little while because this is something that I think I relate to a lot. I have really terrible vision. In my small town, I failed my physical every year with the vision tests that they would do, and they wouldn't let me play contact sports, according to my mom. And then I'm also colorblind, and so I feel like a lot of this distinction between perception and vision is really interesting. I think what's strange about it is even in the cases of the illusions that you just showed us, that when you know that it's there, you still can't see it, even though you know that it's true. And so it's like, I knew that you were gonna trick. I knew you were gonna trick us. I knew that it was probably going to be the one that looked different, that's gonna be the same. But no matter how hard I try, I can't see it. And I have colorblind glasses, and even though I put them on, and I can describe to you what normal colors look like versus how my vision looks, I can describe it to you, and I can see it. but I can't see it in real time. I can't perceive it no matter how hard I try. And that is very strange that I'm just getting blocked. Like, I know that it's there. And I imagine that maybe with some people with like some sort of brain injury, like it's been described to them by a doctor, they know it's there, but for some reason they can't just overcome it. You know, like if perception was something in your brain, it feels like maybe you could just force it to do what you want it to do, but you can't. And I guess I wonder if you have any insight on this phenomenon where you know that it's there, but you still can't see it.
Yes, there's actually a term for this, sort of being unable to shake yourself free from a misperception, being unable to shake yourself free from a misperception. The general term for this is anosognosia. It's like being unable to know something. Anosognosia, being unable to know something. And it's a situation where no matter how much you try to demonstrate to the person, convince the person, right, they are not free from the perception that they are experiencing. This is often used in the medical literature for people who suffer a stroke and lose the ability to walk, usually because one or both of their legs is no longer receiving the signals from their motor neurons in their brain. And so you'll often have a person who's sitting in a wheelchair, for example, and they will say something like, I'm going to go walk to the kitchen real quick and grab something. And they genuinely believe that. And even if you demonstrate to them that they don't have the ability to create tone in the muscles in their legs, even if you can get them to believe it for a second, they still perceive that they're able to walk. And a little bit later, usually what will happen is the delusion will reemerge such that they will continue to express that they could get up and walk to the kitchen if they wanted to. The really interesting part, though, is they will often confabulate and they'll come up with excuses. They'll invent reasons for why they're not getting up to go to the kitchen when they believe that they can. And we think that this has to do with the extent of the brain damage in this particular case, where they'll say something like, I'm just, I kind of want to go to the kitchen right now, but you know what? I've decided against it. I'm not going to. They'll find ways of sort of protecting themselves from encountering this very difficult reality of the situation, right? However, my favorite example of people having a belief that they seem to be unable to shake their brain free from is a pretty extreme example, but I think it's a very effective one. It's from this book called The Three Christs of Ypsilanti. And there's a movie of this book if you don't want to read the book. And I believe Peter Dinklage is in it, if you're a fan of his work. And what happened was, back in the 1950s, there was an asylum up in Michigan that happened to have three people that at the same time, more or less, believed that they were the reincarnations of Jesus Christ. And they were all in the same place. And so the researchers were wondering, well, they understand, based on the basis of this delusion, that they can't all be correct. So what would happen if we put them all in group therapy together? What if we basically forced these people to hang out with each other? Would they all give up on the delusion? That didn't really happen. Some of them, their delusions evolved a little bit, but it was almost as if their brains were not capable of perceiving the version of reality that everybody else around them was perceiving. Their brain was giving them information, and you believe the information that your own brain gives you, right? You have no choice. You are your brain. Your psychological experiences emerge from your biological interconnections, right? And so I don't know. I definitely think that optical illusions are a good way to teach people empathy, because it shows that different people see the world in different ways. Now, that's not to say that we should entertain this, dangerous delusions. We shouldn't say, you're correct. You are, the reincarnation of Jesus Christ. But maybe it makes us a little bit more compassionate when working with people who are not seeing the world in the same way that we are. It is something that is located in the physical brain, as best we can tell based on the research that we have done so far. It would be more accurate to say it emerges from the physical brain, which is a bit more of a nebulous concept.
Yeah, sure. Well, and I think one of the things that people struggle with is for me, what I've noticed with my bad vision is just a lack of empathy for understanding how that could affect the world that I'm in. Like, I think a lot of times, like, especially with driving, when you see something in the distance and it's getting smaller, you're perceiving it as getting, further away from you, but it's not actually getting smaller. But that perception is really important for your, brain to understand how the world around you works, because you just associate when things get smaller. But if you can't sense that because your eyes don't work, you lose a lot of that, I feel like, perceptive ability, because you can't really notice that it's getting smaller. And so you're losing in ways that you don't really understand or get. And so I do feel like with driving, I get a lot of heat because people are just like, how can you be allowed to drive? Well, it's like, one, okay, I need to be able to drive so that I can get places, right? But beyond that, it's difficult to understand, I feel like, unless people are experiencing it. So I think that empathy bit is super important, especially when it gets to other things like mental illnesses or other things like that. And that's where that concept of being unable to believe something, being unable to believe that you have something, I think is very important with mental illnesses. But I do want to talk a little bit more about some of these other brain injuries. When you are teaching people about the ways that your brain can break, are there any examples that you feel like are most interesting to people, or people relate to the most, or like your favorite example of a brain break that just totally confounds people?
Yeah, I've got a few examples. So one actually relates to your example of being able to perceive how far away something is. There is a constellation of symptoms that together is known as Alice in Wonderland syndrome, where your brain usually temporarily loses the ability to estimate the size or distance of objects. This is a really, really good one that I use in my classes all the time when I talk about the visual system, because it turns out we're not directly measuring how big or how far away things are. Your brain has to figure that out. Your brain has to do a series of calculations using its neurons to estimate how big something is, how far away something is. And so it's possible for that part of the brain to break down. This is especially common in children for some reason, such that a child experiencing a migraine or certain other situations, I believe the Epstein-Barr virus is one that can trigger it. Mono can trigger it, wherein they can be looking at an object such as their own hand, or their mother walks into their bedroom, or they're looking at a chair in their bedroom, and suddenly it feels like it's growing bigger or smaller or closer or further away, because that migraine or whatever it is temporarily disrupting the ability of the neurons to make that calculation. So what your neurons are doing is math. And if you interrupt that math, well, you can have all sorts of different consequences. And that's a much easier place to start talking about Alice in Wonderland syndrome than it is to immediately jump into talking about believing that you are the reincarnation of Jesus Christ, for example, or some of these other difficult ones that become tricky, right? So as a biopsychologist, I believe that everything that the brain is capable of is a consequence of the cells sending signals to each other. Just yesterday in my my behavioral neuroscience class, I made the argument to my students at the very end of class, which was very mean of me. At the very end of class, I asked my students, okay, so you feel like AI is not going to take your job because you prefer working with a human. This was after a long discussion and conversation. You prefer working with a human because of the emotional connectedness that you feel with that person. But what is emotional connection at the level of the brain? And I actually asked that question like 3 times before a student, raised their hand and answered it. And they said, it's cells sending signals to each other. And I said, yes, as best we can tell. When you are experiencing emotional connection to another person, it is because certain cells are sending certain signals in your brain. Now, it also involves your endocrine system, but let's not talk about the endocrine system right now. Your hormones are involved, is what I mean by the endocrine system. But once we start talking about the neuroendocrine system, it becomes very difficult to encapsulate the conversation. Things become insane. And so by starting with simpler stuff like perceiving size, distance, color, that sort of thing, you can slowly build your way to some more complicated stuff. Another one that I really like to start with is locked-in syndrome. I have several books about locked-in syndrome that I highly recommend, although they are all very depressing. Like I said, my line of work is very depressing. And depending on how you define locked-in syndrome, you could argue that one of these may or may not count, but We've got The Diving Bell and the Butterfly by Jean-Dominique Bauby. He wrote this entire book using his eyes, moving his eyes in a particular way, because he was paralyzed everywhere except for his eyes. That's what locked-in syndrome is. You damage a particular area of the pons in the brainstem. It's called a pontine infarction, is the most common cause of locked-in syndrome. And it prevents the signals going to your muscles below a certain point. But some of your cranial nerves are above that point. So the ones that allow you to do certain movements in your eyes are actually preserved in most cases of locked-in syndrome, which is why the second book I recommend is called Look Up for Yes. This is by Julia Tavalaro. I highly recommend this book, as you can see by all of my book flags that I have in this book here. And she was able to look up, but because of the location of the damage in her brainstem, she wasn't able to look horizontally. That's called horizontal gaze palsy. And it completely changed her ability to live her life, but also it changed everybody's perceptions of her, especially at first when they didn't realize that she was still in there and she was still conscious, right? So she was taken care of. I use that phrase loosely because they were doing a bad job of taking care of her for several years before somebody was wise enough to start looking for signals that she was still conscious. So they more or less believed that she was in a minimally wakeful state. And when someone started paying attention to her eye movements, they were able to eventually deduce that she was still able to hear everything that was going on around her, so on and so forth. So it's kind of a nightmare situation. They did eventually figure out that she was still in there, but by that time, her family had mostly moved on, and it's a very sad story. But a very, very important book, I think, especially for people that work in healthcare to read. And then finally, a happy one, I guess, Ghost Boy by Martin Pistorius. He had a mysterious illness that, as far as I know, we never figured out what it was, but it produced something similar to locked-in syndrome for a long time, and he recovered from it. So he actually went on to be able to move enough of his body that he is leading a full life now. Which is a nice ending to this trilogy, I suppose. Bauby actually passed away. Tavalaro recovered enough that she was able to communicate enough to write her book, but she was still locked in. And then Martin Pistorius had a much cleaner recovery. So that's one of the first supplementary readings that I assign in my biological psychology class is locked-in syndrome, because it shows a couple of very important things. One, the location of the brain injury matters very much. We can make very good predictions about what the symptoms of a person are going to be based on where in the brain the injury takes place. And second, it really is all about that perception component. How do you experience life as someone who is locked in? There is another reading that I get to later in this semester. We haven't gotten to it yet this semester. That especially is discussed in Ramachandran's book. Here it is. Phantoms in the Brain, which is, as the name phantoms right there suggests, phantom sensations or phantom limb syndrome. If somebody loses a hand or a foot or anything, the brain isn't just going to get rid of the neurons that represented that part of the person's body. It will repurpose those neurons a little bit over time, but some of the ability to sense the world through that piece of the body that is no longer there is still being represented perceptually in the brain. And so you can get a situation where it feels like their hand is moving, or it feels like someone is touching their hand, even though the hand is no longer there in that particular case. So phantoms are interesting because it really shows that the psychological experience of perceiving the world is based on the biological representation of the cells in the brain, if that makes sense. Yeah. And it further demonstrates, depending on where along the brain the body part is represented, we can make predictions about how that recovery from the phantom is going to progress. So, for example, a really bizarre truth is that the hand, certain parts of the hand rather, is represented very close to certain parts of the face in the brain. in this area called S1. Sometimes it has a bunch of different names. That's shaped kind of like these headphones are. If I were to put them back a little further, that's about where S1 is in my brain. And if you lose your hands, there's a pretty good chance that someone touching you on the cheek on the same side of the body where you lost your hands is going to produce this feeling like someone is kind of touching or tickling or poking your hand. Because those neurons that were representing the hands up here, some of them are now partially repurposing themselves. It's like getting a part-time job, is what I like to say. The cortical reorganization theory is like getting a part-time job for the neuron that used to represent the hand that is no longer there. They're going to start firing and reacting when the person is touched on the adjacent area in the brain on the face. Because, fun fact, if neurons don't have a job, if they stop firing, the brain will actually get rid of them. Your microglia and other related cells will cannibalize them. Because it's sort of like, well, if you're not using it, we might as well not pay to maintain these cells. You probably know this, but the brain uses a ridiculous amount of energy. It's roughly 2% of your body in terms of mass or whatever, but it uses maybe 25% of your calories in a given day, give or take. And that's because neurons are very expensive to run, essentially. A lot of that can be blamed on sodium potassium pumps if we want to get into the chemistry, but essentially if you're running neurons that are not doing anything, they're not firing action potentials very often, the brain will often prune them and eventually get rid of them. So what the cells do is if they stop receiving input from the hands, they will try and figure out something else to do based on the neighboring neurons.
I think one of the notoriously difficult parts about doing studies of the brain or doing studies of psychology is that to actually study and influence these things, especially when compared to what people will call like hard sciences or something like that, is it's hard to directly measure or observe these things. And everything is correlational between a behavior and the actual function of the brain. And so we have to make kind of a lot of assumptions, and the way of collecting data is really difficult. And I know that somewhere in this is a distinction between signs and symptoms, but I guess, can you make a case for the legitimacy of, neuroscience, of some of these correlations, of psychology in general, that kind of touches on how we're able to collect this data, why we can trust it, why people can't just lie? Like, how do you figure this stuff out? Like, how can we just trust that this is real? Is there an objective measure for this?
The short answer to that question is there isn't a truly objective measure for pretty much everything that I study. And I can explain why. Let's start with the idea of what a sign is. A sign is something that can be seen, it can be measured by the physician, the person who's trying to make a diagnosis of some kind. A classic sign would be if I take a blood sample from somebody and I look at what the blood sample contains, I can find a sign that the person has a particular blood type, or the person might have sickle cell anemia, right? I can look at it and I can say there's a sign here, here's something that I'm objectively measuring. Getting a little bit further away from signs, we have behavioral signs, which are not true signs, but they're as good as a sign as we have in my area of discipline, which is psychology. Which, for example, if I have somebody and they are sitting in their chair and they're doing this, right? They're rocking back and forth. Well, if I'm going through a checklist diagnosis of some kinds, so for example, if I go through my diagnostic and statistical manual here, which we use to diagnose generalized anxiety disorder, for example, I could, on my checklist, say this person appears restless. This person appears agitated because they're doing this in their chair. Not quite the same thing as taking a blood sample and saying, I've detected this thing in your blood, because there is interpretation there. I'm interpreting the behavior of what the person is doing and assigning it some kind of a label. Right? So that's a behavioral sign, a little bit different than a physical sign, a true sign. And then on the far end, we have what's called a symptom, which is something that is self-reported by the person, self-reported by the patient. Going back to our phantoms example, one of the most unusual things that happens when a person experiences a phantom is that they hallucinate, right? They experience the hand being there, that it's not actually there, because the neurons have to fire occasionally so that they don't die. Yes. So you get this situation where the person will say, oh, it feels like someone's touching me on my hand. It feels like I'm experiencing pain in my hand right now. And I just straight up have to trust them, right? There are things that I can do to make it a behavioral sign. If I have them wired up to a particular brain scanner, I might be able to say, oh, there's more activity in these brain cells, right? There's something I could do with like a brain scanner maybe. But even then, an activity in a brain cell is not necessarily the same thing as, oh, I'm experiencing pain in my hands. And so brain scans are actually still behavioral measures. They look pretty impressive, like fMRI, right? Functional magnetic resonance imaging. I can show you lots of different colors of different brain cells lighting up. What I'm actually showing you is the amount of oxygen that's being used by different parts of the brain. They're taking oxygen out of the blood in order to run those sodium potassium pumps that I was talking about earlier. But even then, I don't actually have the ability to say for sure that this neuron or this group of neurons using oxygen is the same thing as this person having a specific experience. Take pain, for example. Pain is the best example of a symptom because there's no way for me to prove or disprove that a person is or isn't experiencing pain. It doesn't matter how much I scan their brain. I can even record from single neurons and I still won't know whether the person is experiencing pain or not, because the way that the body experiences pain is extremely, extremely complex, to the point where I don't envy pain researchers. Think about it this way. Pain is a very important signal. It has to get through. The body wants to get the pain signal through because it believes that you are in danger, right? And so even if you ablate nerves, even if you try and get in and like completely change how the pain network is set up in the person's body, the pain is going to do its very, very best to find a way through such that the person continues to experience the pain. And we know that pain is an important signal because of a disorder called congenital pain insensitivity, or congenital insensitivity to pain, where a person can actually be born without the ability to experience most types of pain. Those people often die very young because they will get severe burns and they won't really notice at first, or they'll bite off pieces of their tongue and start bleeding because they don't know that they've bitten their tongue because they don't get that feedback, right? Anyway, you have this claim that you're experiencing pain, but we're trusting the person. The way that we measure pain is asking them, hey, how much pain are you in? And that's all the better we can do. We get people who say that they're in more pain than they actually are. Maybe they're trying to get painkillers, and so they'll say that they're experiencing severe back pain when in reality they're not. And we also have people that say they're in less pain than they actually are. They're trying to act tough, perhaps. So you'll get people that say, oh, I'm at 1 on the pain scale when they're actually at a 9, and they're like crying and like their whole body is red. And it's like, well, I think you're probably at more than a 1. And they're like, nope, this is nothing. I can handle it, right? So it's about trust at the end of the day when it comes to symptoms. We would really, really like it if over time we could start making things that are right now more symptom-ish into things that are more sign-ish. And like how brain scans get us a little bit closer, we are starting to find certain biological correlates for certain things. Unfortunately, progress is extremely slow. So a really key example right now is schizophrenia research. I pronounce it schizophrenia, by the way. I know most people say schizophrenia. Both are correct. But schizophrenia is how I learned to pronounce it in my radio speaking class. So that's what I'm going with. And essentially what happened was we had these researchers back, some of them all the way back in the 1800s, that were combining lots of different things going on in the brain into one disorder that they started calling schizophrenia. It's a heterogeneous condition. Lots of different stuff can be going on in the brain, and it produces symptoms that we then have to try and interpret, and we have to give a label to, right? So we go through and we say, oh, they're exhibiting this or they're claiming this, right? The 2 biggest hallmarks of schizophrenia, according to the current diagnostic criteria, are positive symptoms and negative symptoms. Positive symptoms are things that are there that shouldn't be there. So hallucinations and delusions. Hallucinations such as hearing a voice that isn't there, feeling like you're being touched on a hand that isn't there, that's a hallucination. And delusions, like we were talking about earlier, having beliefs that are not true. And then negative symptoms are when there's something that should be there but isn't there. So a common example of that is avolition. People who don't want to do anything, they just kind of stay in one place and, talk to themselves, for example. So those are both behavioral signs to an extent. Like I can say this person's been sitting in a corner talking to themselves for several hours. I would say that would be measured on my diagnostic criteria. A really common one to use is the positive and negative schizophrenia scale, the PANSS. But it still requires a clinician to fill out all of the numbers. But then how do you fill out the numbers for hallucinations and delusions? It becomes a lot harder, right? You have to kind of hang out with the person and listen to what they're saying and sort of interpret whether what they're saying is true or not true. And fun fact, everybody believes things that are not true. And everybody hallucinates sometimes, especially if you stay up and don't sleep for long enough. Like you experience things that are not real. Like the brain just does that, right? There was a really famous study, what decade was this? I think the 1970s. I could be wrong on that. Where they went through objectively through the diagnostic criteria at the time, it has since been updated, to see if certain people would fit the diagnostic criteria for schizophrenia at the time. And what they found is basically everybody qualifies. If you sit there and try your hardest to put everyone in the box, you can put everybody in the box. So anyway, my point is, it would be really nice if we had a sign. It would be really nice if we had a sign for schizophrenia. That way we don't accidentally put people in the box that shouldn't be in the box for schizophrenia, right? We don't want to misdiagnose people, right? It's one of the worst things you can do is put somebody in a box that they shouldn't be in. You're actually making their life worse by giving them a label that they shouldn't have, right? Okay, so several years ago, they found a correlation in the brain between ventricle size and a diagnosis of schizophrenia. Are you familiar with this one? Ventricle size and the diagnosis?
Mm-mm.
So the ventricles are open areas that are full of cerebral spinal fluid. And there's this correlation. The bigger your ventricles, the more likely you are to be diagnosed with schizophrenia. Does that mean that I can use ventricle size to diagnose schizophrenia?
Probably not. No.
The answer is no. Unfortunately, no. Because there are people with big ventricles that have none of the symptoms, and there are people with small ventricles that have tons of symptoms. Wherein, even though there's this biological correlation, there is overlap in the two groups when it comes to doing the measurement. I can draw the line somewhere, but no matter where I draw the line between those two groups, I'm going to end up with false positives and false negatives using that criteria. Okay, so what about genes? Here's one that people love to point to when it comes to schizophrenia. I have very bad news about the research in schizophrenia when it comes to both the twin studies, the family studies that they did, I think in the 1980s were when most of those were done, as well as the much more recent genetic stuff that was done in the early 2000s up until very recently. We were confident that we could find some kind of biological marker in the DNA, or a combination of biological markers in the DNA that would, at the very least, predict some of the schizophrenia. Remember, it's a heterogeneous condition. So there are people with different things going on in their brains that all end up with more or less the same diagnosis. And what happened was we spent over $1 billion of research money collectively as scientists trying to pin down a gene or set of genes that would reliably predict a percentage of schizophrenia cases, and maybe even give us some kind of ability to treat it, right? Some kind of ability to edit the genome, fingers crossed. That's still something that's extremely controversial, but, maybe someday. And we ended up kind of back where we started, unfortunately. We got overconfident. If you look at the history of psychiatry, there's only really been one time that we were able to find a biological treatment such that some people could be cured. And that was back when syphilis was not being treated in a lot of insane asylums. As soon as they figured out how to treat syphilis, a bunch of people who were insane got to go home because we were able to figure out what the pathogen was and we were able to treat it. And so I think it was, I'm going to get this number wrong, but it was like a double-digit percentage of people in insane asylums basically got to be cured and go home. Huge deal at the time. And then psychiatry kind of reacted to this by like trying a bunch of other biological interventions that are very dark and horrifying. And we could talk more about those later if you're interested. But they started trying stuff to see if they could cure anybody else, and they haven't really been able to. It seems like whatever's going on when it comes to schizophrenia, OCD, major depressive disorder, generalized anxiety disorder, all of the modern diagnoses is complex enough that I can't just point to one gene and say, there's your explanation. Or we're just not doing the right research or looking in the right place. I mean, I still am a biological person at the end of the day. I do still think that there's progress that can be made in this area when it comes to like narrowing down the trial and error that needs to be done to try and assist people. But it's not as straightforward as we thought it was going to be. Like, think about how amazing it would have been if we had found, oh, there's the genetic marker. Everybody who is experiencing this is cured. You can go home. Think about how amazing that would have been if we had been able to do that with the Human Genome Project. If you go back and read some of the literature about the Human Genome Project, the first time that we sequenced the DNA of a person, people were so optimistic, especially about schizophrenia. They were like, "Oh, we're gonna have this fixed in 20 years," and now it's like more than 20 years later, and we do not have a fix. I'll tell you what they're trying right now, though. Are you familiar with organoid research? They can grow teeny tiny brains in petri dishes. Radiolab did a podcast episode about this called Brain Balls in January of this year. And effectively, someone accidentally grew a brain in a petri dish, and they realized that they could use that to study certain disorders and diseases of the brain. So they use it to study brain cancer, so on and so forth. They'll actually take part of a person, they'll grow a tiny brain using their cells, and they'll take a part of their brain tumor and they'll grow that, and then they'll combine them somehow. I don't know the science of that part. And then they can test different treatments to see if they can kill the tumor without killing the brain, the mini brain, the organoid brain, right? There are lots of ethical questions about this, like, oh no, is that tiny brain capable of thinking? Most people say no, but I don't know. We don't really know why our brains are capable of thinking, so it's kind of a philosophical mire, unfortunately. So I guess my point is, we're still trying stuff. We're trying these organoids to see if we can learn anything about the basis of schizophrenia and other things that are going on in the brain. But I mean, whatever it is that's going on, we kind of have, unfortunately, gotten ourselves into a situation where we are not quite back at square one, but we have been working on trying to figure this out for a very long time, and we're not at a point where we can make physical diagnoses. We can't use physical signs yet to diagnose these things.
Yeah.
And that sucks, because whenever you're using a behavioral checklist, behavioral diagnostic criteria, you end up with extra false positives and false negatives, and people end up on medications that have side effects that they probably shouldn't be taking, and people get missed that probably could have really used a therapeutic intervention of some kind, and both cases are not ideal.
Yeah, I really want to talk about some of these mental illnesses, because I think that inability to perceive that you have a mental illness just sounds so horrifying to me. Like, the idea of schizophrenia, it just sounds terrible, that even if you knew you had it, that wouldn't just solve the problem. Like, you wouldn't be able to just trust that the things that you're hearing aren't just happening. Because it could always be true that your brother is like whispering behind the door or something, and you actually are hearing him. You know what I mean? Like, you're so susceptible to the world around you when you're in a position like that. And I think that this is also true for some of those common ones, like generalized anxiety disorder or maybe depression of some sort, that these things, it's like, well, you could be sad because your life genuinely sucks. Like, it might not be a result of, whatever symptoms. Like, things could just be stressful right now, and that's why you're anxious. And so I think it's so hard to put the onus on a person who has one of these things to try to like always figure it out, like the mental energy that it would take to find out the truth about the world that you're in, given any of these things, just sounds horrifying to me. I do think that there's a general narrative right now that some of these things are either overdiagnosed, they don't exist, like some of these mental, not maybe with schizophrenia or maybe bipolar or OCD, some of those I would say more like serious ones, but you do have things like there's an idea out there that we are overdiagnosing anxiety, depression, and stuff like this. And so I guess like, how do you plug yourself in as somebody who studies the brain? Do you have like a way to say that maybe this is more real than what people are saying it is, that like it's actually easier to diagnose, or we should be taking this seriously? Like, I guess, what's your defense of like the scientific evidence for some of these mental illnesses?
Yeah, I mean, the answer to that is extremely nuanced and complex, which is part of my answer. So let me start with a way of thinking about mental illnesses that maybe most people don't consider. What a mental illness is a person experiencing enough dysfunction in their life, and it's causing enough distress in either themselves or the people around them that they end up seeking help of some kind, or someone seeks help for them, right? And from there, we try and figure out what category to put them in. But what mental illness actually is a disorder of attention, a disorder of attention. In OCD, you're focusing on details to the point that you are causing detriment in other areas of your life. You're washing your hands so much that you lose your job because you don't go to your job because you're washing your hands, for example. That's a stereotypical example, but it is one that shows up in the literature from time to time. In schizophrenia, you are paying attention to delusions and hallucinations instead of paying attention to the quote unquote real world and the people around you. What will often happen, as I mentioned, is you are paying so much attention to voices that you are hallucinating that you're not paying attention to the voices of the other humans that are around you, for example. In generalized anxiety disorder, you're paying too much attention to the future. In major depressive disorder, you're paying too much attention to negative things that are happening or going to happen, or some people will even just say the past in general for depression. That's a bit simplistic. But essentially, you are experiencing things by putting more attention into those things. And something that would really help you is if you were putting your attention somewhere else, right? That's a simplification, but it is a way of thinking about mental illness, right? And so what we're really trying to do when we are treating a mental illness of any of those kinds, or anything of a similar kind, is anything that will get the person to focus on something else. Anything that will get the person to focus on something else. We can also put ADHD in that category. ADHD is something that people will commonly say is overdiagnosed these days as well, right? So let's put that in the category as well. Which ADHD is probably the one that's most obviously attention. It's in the name, right? Paying attention to certain external stimuli instead of certain internal stimuli might be a way of saying what's going on with ADHD. The stereotypical example on a TV show or a movie, you're distracted by something that happens, like a squirrel running by, right? And then you're not paying attention to the fact that you have homework that you need to be working on, for example, right? So paying more attention to the external than the internal world might be a way of thinking about that. Okay, so if these are all examples of misaligned attention, then that kind of changes the question of what we're trying to do as someone who's trying to diagnose and treat a disorder, right? If the person refocuses their attention, does that mean that the person no longer has the mental illness? Let me put it this way. I personally think it's incorrect to say that a person has ADHD, has schizophrenia, has generalized anxiety disorder, has major depressive disorder, or has OCD. I think the correct way of saying it, and this is pedantic of me, is to say that the person has been diagnosed with it. I have been diagnosed with ADHD, I have been diagnosed with OCD, I have been diagnosed with generalized anxiety disorder. Because remember, we're using those behavioral checklists. And if something happens in that person's life, such that their attention is then shifted, it focuses on something else, they're no longer caught in the loop in their brain that is paying attention to quote unquote the wrong thing, then suddenly they no longer meet those diagnostic criteria and they no longer have the thing, right? So I think it's incorrect to think of these as diseases. and to think of them as something else, to think of these as diagnoses that are describing a current situation that a person is in. So I absolutely agree with your assessment that sometimes a person feels depressed because the world is genuinely shitting on them. They're having a bad time, right? A certain amount of depression is an adaptive response to the world. Same thing with anxiety. Having a certain amount of anxiety is adaptive to the world, because anxiety, again, is thinking about the future. If you never think about the future, you're also in trouble. Thinking too much about the future, getting too invested in it, worrying beyond a normal, quote unquote, whatever normal means, a normal amount, that's when we start saying that anxiety is maladaptive, right? Do you get into these situations where not only can the experience of the person's life shift such that they no longer qualify for a diagnosis, but we go back to that behavioral checklist of some kind. It's possible that if you go to two different clinicians, one of them will try to put you in box A, and then the other will say you actually belong in box B, or you might get a clinician who says you don't qualify for this diagnosis, right? So the boxes that we draw between these different diagnoses are, by necessity, artificial. We use what's called consensus reality. We get a bunch of experts into a room together, and we have them draw the boundaries for each of these different conditions. And every time we create a new edition of the DSM-5 TR, or whatever diagnostic manual you want to use, the ICD-10 is another popular one, we redraw the boundaries a little bit. So I guess the question to ask is, are the boundaries changing in such a way that we are diagnosing more people with these conditions? And the answer to that is, broadly speaking, yes. We have right now what's going on in the field, a one-way ratchet situation, where every time we create a new edition of the diagnostic manual, we find more ways to include more people in more diagnoses. And we're not necessarily doing this to make more money, quote unquote. We seem to be doing this because we genuinely want to give people a helpful label. We seem to be doing this not necessarily because we're being malicious, but because we're trying to create a situation where if someone says that they are in enough distress and dysfunction, or the people around them say that there's enough distress and dysfunction going on, that we have a label that will work for that person. And the motive there, you can argue, partially is because we need to tell the insurance companies what's going on. We have to have some kind of a number from the DSM-5 or the ICD-10 that we can use and say, this is what I'm treating this person for. So part of it, the labeling isn't even necessarily just for the person. It's also partially for the insurance company. But a lot of people enjoy it when you say to them, hey, this is what I think the name of the thing you're experiencing it is. A lot of people will actually report being thankful when they're given a label. Now, there are downsides to being given a label as well. But a lot of people will say, oh, my life changed the day that I was told that I have ADHD. Again, I would say was diagnosed with ADHD, but most people shorten it, and I can't blame them. It's a lot easier to say have, right? But they treat it almost as if it were an explanation of their symptoms. And this is the key point. This is the key point. It's not an explanation of their symptoms. It's a description of their symptoms. A mental illness diagnosis is a description of what we think is happening with that person based on those behavioral checklists, a combination of behavioral signs and self-reported symptoms, such that we're trying to figure out how to put you into a category that we have created for the purposes of putting people into the categories. But we're just describing what is happening. We're not actually explaining it. I don't know what your neurotransmitters are doing. I don't know what your neurons are doing. I don't know what your genes are doing. I don't know what your life is like in some cases, because maybe I didn't ask, right? I think recently they got rid of the bereavement exception in the DSM for major depressive disorder. I would have to check on that. But for a while, we had this exception carved out for people who recently lost a spouse. Don't diagnose them with major depressive disorder. It makes sense for them to be really depressed right now. They lost a spouse. And they dialed it back and or got rid of it. I don't remember which is correct in the current version, the DSM-5 TR, and I'm not going to read all 1,000-something pages of this right now, but it was dialed back to an extent where now it's easier to give a person who is bereaving their spouse an antidepressant now because they get the diagnosis and then they get the antidepressant than it was a few years ago, right? However, the universe does not care if we can explain it. The universe does not draw neat boundaries between things, and it does not care if we are able to understand it and make explanations that work for our brains. And so we end up in a situation where people are probably being overdiagnosed. You can make the argument that part of it is also the pharmaceutical companies because they're trying to sell their drugs and they can put undue pressure on people to expand the diagnostic criteria for things. There might be some evidence of that. But regardless of why it's happening, it does seem like the diagnostic net is expanding. And there are several specific examples that I can give you. And there's lots of great literature that I can recommend. I have a whole stack of books about this because I teach drugs and behavior, remember? But one key point that I love to make, because people can relate to this because it's in the news all the time, is what happened recently with autism spectrum disorder. So if you go back a number of years, we had the diagnosis for autism, we had the diagnosis for Asperger's, we had some different things going on in the, at the time, current version of the DSM. And then everybody got together and changed up the definitions a little bit. They had these long conversations around tables trying to figure out what would be best for the patients, what they saw in their caseloads. They got together and they made, using consensus reality, a new set of diagnostic criteria. And they created a spectrum, the autism spectrum, as we can call it for short. So what ended up happening is more people qualified specifically for a diagnosis that on paper said autism spectrum disorder, ASD, and they got rid of Asperger's, for example. And also the public awareness of autism was increasing at the same time. More people were being tested for it. More people were creating organizations that would talk about autism in a positive light, which I think is great. You know, I think empathy is a very important thing to have. And what ended up happening is the number of people being diagnosed with autism spectrum disorder, which most people just shorten to autism still, went up. And at least, according to the numbers I've looked at least half of that increase is attributable to the fact that we changed the diagnostic criteria. There's a specific set of books and articles, and there's even a New York Times article recently that acknowledged this, which got a much broader reach. Like, a lot of people read that. So when they saw that, like, oh, 50% of this can just be attributed to the fact that we redrew the boundary of what counts as autism, maybe we're panicking for nothing, right? But, and you probably know where I'm going with this, for a while, people started blaming something else for the increase in the number of autism diagnoses. Hopefully you know what I mean.
The vaccines, yeah. And I think people are always looking for answers for stuff like this. And maybe this is just the sentiment, especially with the Genome Project too, and trying to uncover these things, that it becomes very useful to have a solution to these things, especially if the same company that is making the drugs that solve these things or making money off the diagnosis of doing these things are the same company who is doing the research to solve them as well. But beyond that, we've been running for about an hour, so I want to give you the opportunity to kind of round us out. So if there's any thematic messages or any plugging you want to do for either your channel or any of your books or anything like that, this is really your opportunity to kind of round us out and speak to the people who have made it this far in the episode. So just go ahead and round us out, Xander, and then we'll wrap it up.
Yeah, fantastic. Well, first, I guess I need to take a step back and make it clear that I'm not anti-psychiatry. I do think that it has its use cases. I do think that there are situations where maybe people shouldn't be taking a drug, but I also think it's a bad idea to stop taking a drug suddenly. So if you're ever in a situation where you're trying to change your medication regimen, do so working with a medical professional, and also go slowly. And, be careful, I guess is my case. So the other thing that I'll say is that I think in 100 years, we're going to look back at this period and we're going to do the same thing we do when we look back 100 years and we say, wow, they really had no idea what was going on. We're trying our best and we have made progress from where things were 100 years ago. In 100 years, I think our species is going to look back and say, we had a lot more work to do. And then guess what's going to happen? Another 100 years is going to pass and they're going to feel the same way, right? So we are making incremental progress. Things could be better, but we are making incremental progress. But yes, so I wrote a book, as we mentioned earlier, called Incredible Consequences of Brain Injury: The Ways Your Brain Can Break. And this is, I think, a very good primer into some of the different ways that a person's perception of reality can change after a brain injury of some kind. There are case studies in every chapter, a minimum of 3, telling stories from real people's lives and how they were affected by these different conditions. And I think it's very important to center the human, especially as a psychologist, to remember the human when we're talking about these different conditions. These are real experiences that real people have. And then, of course, my YouTube channel. You can probably tell from the fact that I have a ring light and a couple of other camera-related things set up behind me that I'm working on doing some more work on my YouTube channel. I'm not sure when my next video is going to go up, but it is something that I am actively working on, and it's something that I've been running since, I think, 2014. I've been making channels on there, so if you want to see what I looked like as a youngin' just trying to get started, I have my old videos up on there still. Otherwise, a lot of my more recent work has to do with the ways your brain can break and similar neuroscience questions. So I also think the most important thing to shout out right now is just science in general. I think that it's really interesting for us to talk about the shortcomings of science and the limitations and the things that we don't know. But I also think it's really important to keep in mind, just like with the vaccines that we mentioned a moment ago, that we need to not take for granted the things that science has provided for us so far and the promises that it holds to continue to make the world a better place for people as we continue going forward. So even though I'll often make videos about like, ooh, snafus in the history of science, it does more good than harm to study science when we learn about the world as objectively as we can. I do think that there is something to be said for prioritizing and cherishing both science and science journalism, especially in a world right now where people seem to get so wrapped up in, who knows, themselves or the pursuit of profit even, that they sort of forget about just how beautiful the natural world is. And I don't know, if anything, I think, I really want people to spend more time reading science books and getting into just how big and beautiful the world is. And if anything, it'll help you focus on something a little bit more real, something that we can actually make progress in, as opposed to getting caught up in the news cycle where, you benefit from reporting on maybe things that are a little bit more negatively valenced. There are still beautiful things in the world, and I think science allows us to access those things. So yeah, shout out to science, honestly.
Yeah, well, thank you so much for coming on, and it was a pleasure talking to you.